Okay, today we're going to be talking about actually graphing a quadratic, and we're going to learn to do it today in standard form. There are other forms that we're going to learn later on. So we're going to learn what the standard form of a quadratic is, what the graph of that quadratic looks like, and how to graph a quadratic. So basically, these are all graphs of a quadratic. They open up if your x squared is positive, they open down if they're negative, and they're all symmetric, meaning we can fold it in on each other, on itself. So here's the standard form of a quadratic. Y equals ax squared plus bx plus c. The a squared, if the a is positive, it opens up. If it's negative, it opens down, down like a frown, up positive like a smiley face. Our linear term is b, and c is always our y-intercept. So this is going to all help us to graph this quadratic. So now when I look at a quadratic, this is my vertex. And in this case, that vertex is a minimum. Okay. Now through the vertex is this vertical line. Oops. Right here. And we call that the axis of symmetry. Okay, and that's where I can fold my graph around that line. It's a vertical line, so it's always going to be x equal whatever the x coordinate of our vertex is. So in this case, it would be x equals 3, and actually our vertex would be the point 3, negative 3. This point right here and this point right here, like we learned in the last lesson, are our roots, our zeros, and our x-intercepts. And then we have our y-intercept here. Okay, and how we find these things, all of them have something to do with the equation. All right, so we also have the domain and the range. And in the case of a quadratic, and this is just all written on your notes, the domain is just our set of all x values as any domain. And in every quadratic that we're going to do, it is x as an element of the reals, or it's going to go from negative infinity to infinity. The range being the set of all y values, it's either going to be greater than or equal to the y coordinates of the vertex, or less than, depending on whether it opens or up, down or up. If it opens up, it's going to be greater than. If it opens down, it's going to be less than. So let's take a look at a couple examples just so that you can see the key points. In this vertex, this is the one that we just had. So we know what the axis of symmetry is. We know what the vertex is. My vertex is right here. It is 3 and negative 3. So my domain is all reals. So x is an element of the reals, or in interval notation, negative infinity to infinity. Because this graph opens up, my range is going to be y such that y is greater than or equal to this negative 3, my y value. In interval notation, it's going to be negative 3 to positive infinity. For my second example, I want you to notice that my vertex, or the vertex is here, and that is negative 2, positive 4, and it opens down. Now, our axis of symmetry, if the equation for that is going to be x equal to negative 2, or the x value of the vertex. Okay, my domain, I'm just going to write a D, is going to be the same as the other one, right here. They're going to be that way for all of our parabolas. The range in this case is going to be less than because it opens down. So y such that y is less than or equal to 4. And then in interval notation, remember we start with the smallest, so negative infinity to positive 4. Okay. Here are some really big bad steps for graphing. First thing we have to do really is just determine A, B, and C. And the A and the B are going to be important. The C is going to be our y-intercept. Okay. And so we can find the x value by using this formula, x equals negative b over 2a. Again, you're going to have to memorize that. I'm not going to give that to you. Once we found that, we can find the value of the vertex by subbing it in. And then we're going to put it into the equation and we're going to simplify. All right, now this is kind of very simplistic. This over 1 and up 1 squared times whatever a is. So I'm just going to go back to the slide. And what I want you to notice is that from my vertex, I'm going to go over 1 and up 1. And then from my vertex again, and it happens on both sides, I'm going to go over 2, and then my next point is going to be up 4. Okay, well, 2 is 4 squared, or 4 is 2 squared. If I were to go over 3, I'm just going to do it off to this other side, and I would count up to the next point. I'm going to go up 3 squared, or 9. But we're doing this all from the vertex. Okay, so let's look at an example to graph. All right, so here's my equation. I know my A is 1, my B is negative 8, and my C is 17. So C is going to be my y-intercept, which we're not going to be able to see on this graph because it's not big enough. But to find my x coordinates, I do x equals negative b over 2a. In this case, b is 8, so it's negative of a negative 8 over 2 times 1. Okay, so x is going to equal 8 over 2 or 4. Okay, so that's actually my equation axis of symmetry. Okay, but if x is 4, in order to find y, all I have to do is put it in for x over here. So y is going to be, we've got x squared minus 8x plus 17. So x squared, so 4 squared, minus 8 times 4 plus 17. Okay, so I'm going to get 16 minus 32 plus 17. All right, and when I put that all together, 16 minus 32 is negative 16 plus 17 is 1. So this is going to equal 1. So now my vertex is going to be 4 and 1. All right, so to graph this, we're going to start at 4, 1, which is our vertex. Right here. Now, we're going to go over 1 and up 1 from the vertex. So I'm going to go there. I'm going to do the same on both sides. Then I'm going to go over 2 and up 2 squared, which would be 4, on both sides of my axis of symmetry. And there is my parabola. And that's all there is to it. Okay, so let's look at this next one. So we have, all right, so again, we're going to do the same thing. We're going to find the x coordinate of the vertex. So we're going to start with A. being 1, B being 4, and C being 2. Now here's the nice thing with C. Right away, we've got this on my graph, and I know that this is my y-intercept. Okay, so I'm just going to go right over here, and I'm going to graph that right away, and I know I have a point. All right, so again, my x-coordinate, we're going to use that. I don't know why this keeps doing this tonight. X equals negative b over 2a. So in this case, I'm going to get x equal to negative 4 over 2 times 1, or x equal to negative 2. Okay. So I'm just going to plug it back in. So y into my equation. I want you to be, so my equation is x squared plus 4x plus 2, and it's y equals. So negative 2 squared plus 4 times negative 2 plus 2. So I'm going to get 4 plus a negative 8 plus 2, which is going to equal negative 2. So my vertex is negative 2, negative 2. So negative 2 is right here. Now you have that axis of symmetry, so I can go 1, 2 over there and 1, 2 over there, and I know I've got a point. But then I'm going to go over 1 and up 1 from the vertex for my other point. And if you just wanted to double check, I would go over 2 and up 4 for my other point, which is actually where that is. And it makes this nice little U. Just like that. All right. Doing one more example. And actually, I think I might have changed this on your sheet. So hold on a quick second. All right, I didn't. So we'll just go right on from here. All right, so we're going to do our A is negative 1, B is negative 2, and C is negative 4. Again, that's my y-intercept, so I've got that point right there. To find my x-coordinate of the vertex, x equals negative b over 2a. So x is going to equal negative of a negative 2 over, got a little carried away there, over 2 times negative 1, or 2 over negative 2. So x equals negative 1. Now I want you to be very careful with this negative sign. Okay? Remember, this negative x squared minus 2x minus 4, okay, there is a 1 in front of there. So this is the same as saying negative 1 times x squared minus 2x minus 4. Now I'm going to sub in my negative 1. So I get negative 1 times negative 1 squared minus 2 times negative 1 minus 4. So if I follow order of operations, I'm going to square the negative 1 first. It's going to give me positive 1. So negative 1 times 1 minus 2 times negative 1 minus 4 is going to give me negative 1 minus negative 2 minus 4. Plus plus, it's going to give me negative 3. So my vertex is going to be negative 1, negative 3, right here. Okay, because this is negative, it opens down. So I'm going to go over 1 and down 1 on each side. My y-intercept's already there. Then from the vertex, I'm going to go over 2 and down 4 to here, and there's my point. All right. So I kind of threw a little bit at you. Just remember that a quadratic will always graph a shape, this parabola. If x squared is positive, it opens up. If x squares, it's negative down, and it's symmetric. I shall see you in school tomorrow. Have a great day.